Now, from the question, we know that A, B, C are positive integers, and B is square root of A times C. Then how can we determine is that now for MC, we can just substitute for in the equation different values of A, B, and C. So I try A equal to 1, and that because with B equal to root AC, so I choose C first. Then I take C equal 4. Therefore, B will be 2. Then this will satisfy the condition that A, B, C are positive integers. Now, by using these values of A, B, C, then we can uh, substitute in the option 3. Option 3. Now, for option 3, then you will see that a to power 4 to power A is 4, and then 4 to power B is 4 square, which is 16, and then 4 to power C is 4 to power 4, which is 2, 5, 6. Then clearly this is not an GS, not a GS. So 3 is wrong. So by this question of MC, you can see that if 3 is wrong, then the answer is A, 1 and 2 only. So that's all for this question. However, you may be curious that how can we determine 1 and 2 are correct? Okay, if this is not an MC question, then how can you determine or that there's different options in A, B, C, D, then how can we know the correct answer? Now, then we need to go back to the different condition. B equal to root A C. Now, for this condition, then we can write B squared is equal to A times C. And if we divide both sides by AB, then you can get B over A is equal to C over B. Then it means that if we consider the ratio of B to A, then this will be the ratio of C to B. So it means that A, B, C is a GS with common ratio R. ABC is a GS with the common ratio R. So actually, this is if, the conclusion that if B is root AC, then we can say that ABC is a GS. Now, then by using this property, then we can determine 1 and 2. Now, let me look at the uh, option 2 first. Look at option 2 first. This one. Now, if ABC is a GS, then how can you know A cube, B cube, C cube is a GS? Now, if this is GS, then with A cube is a first term. How about B cube? Now, because B is A times R, okay, ABC is a GS, so B is A times R. So B cube will be AR to power 3, which is A cube and then R cube. And then next, how about C? Now C to power 3 will be AR square times AR square to power 3 because C is the second term at the third term, so it will be AR square. So it will be A cube and then R to power 6. So you can see that if we look at the first term A cube, second term A cube, R cube, A cube times R cube, and then A cube times R to power 4, R to power 6, then this is also a GS. And the common ratio is R to power 3. So option 2 is correct. Okay, now then last one, how can we determine the first option? Okay, now we need to look at A and log A square, log B square, and log C square. Now then with the sequence not A square, okay, this is the first term. How about log B square? Now because B is AR, so it will be log AR square. So it will be log A square times R square. Now for the logarithm, then we can write it as log A square plus log R square. So it is log A square plus 2, sorry, not R square, log 2 log R. So this is the second term, log B square. And how about log C square? For log C square, because C is AR square, so I can have log C square right as log A square times R to the power 4. So it is log A square plus log R to the power 4. So it is log A square plus 4 times log R. So you can see that the first term is log A square, second term is log A square plus 2 log R. Third term is again log A square plus 4 log R. So it means that log A square, log B square, and log C square is an AS with the common ratio, not common ratio, sorry, with the common difference equal to 2 log R. So the option 1 is correct. So this is why the answer is A.